All right, I think we'll kick off. How's everyone's day been today? A little thumbs up? Nice, nice. Good to see, good to see. Well, very excited to be closing off the first day of the LF Summit here today. My name is Zak Watts, and depending on my energy level, some of my friends call me megawatts or like gigawatts. But yeah, today I'm joined with Sukh, and we're going to be talking about open source solar forecasting. I joined Open Climate Fix, which is where we're from, about a year and a half ago. Previously, I did my master's in physics, spent a bit of time working in some science laboratory spaces, before then getting swept up by the whole AI wave that's sort of taken a few of us by storm in the last couple of years. And I'm joined today with Sukh.
Hi everyone, I'm Sukh. I'm a machine learning engineer for Open Climate Fix. I've been working there almost 6 months, or just over 6 months. Previous to that, I also worked in energy tech, working on EV charging optimization and load forecasting.
Thanks. And today we're going to be talking about our open source solar forecasting journey that we've been on. So a couple of months ago, around February, March time this year, we launched Open Quartz, which is our open source solar forecasting model that anyone can use in a couple lines of code. Really easy, quite plug and play. We're going to be speaking about not just Open Quartz, but some of the other things we do at Open Climate Fix, and our open source journey, some of the challenges that we've had along the way, and some of the solutions and successes that have worked well for us. So yeah, going to start off with a brief introduction to us as a company, Open Climate Fix, why we've chosen to do solar forecasting, and what are the current solutions that we have in place, as well as what we've been doing to keep it open, including speaking a bit about what we've been doing as part of the Google Summer of Code project. And then we're going to touch a bit upon Open Quartz, some of the developments that we've been having in our model over the past 6 months, and then what is next in store for us. So this is a picture from our offices in London. We work in the Sustainable Ventures co-working office space. We're a small team of about 12 people. The company was originally founded in 2019 by Jack Kelly in the red there and Dan Travers in the shirt here. Jack Kelly at the time was at Google DeepMind, and Dan Travers was at doing electricity trading. And they came together with the aim to maximize the impact of what they can do in terms of climate change mitigation. And since then, we've been developing open source AI solutions to decarbonize the electricity grid. And between the team, about 40 years of experience in AI and energy, and we try and do everything that we can in the open. So that means open data sets, open code, and open models as well, which we're going to talk a little bit more about later. So we see Open Climate Fix as trying to solve this problem that exists between industry and researchers, where there's often really great research happening, but a lot of the time that research isn't going across into industry for various reasons. And so what we've done at Open Climate Fix is we work really closely with researchers at different universities, but also within our company ourselves, and the industry as well, to find out what are the specific problems that they've got, and how can we create solutions which there is a demand for. So we see us sort of traversing this mountain of pain, so to speak. So why have we chosen to do solar forecasting? Well, solar forecasting is forecasted to be the largest source of electricity globally by 2040. It currently makes up of about 6% of the electricity generation globally at the moment, and it's going to present a large source of uncertainty in balancing the electricity grid as it grows more and more. And this uncertainty comes about because by nature, solar and other renewables like wind are variable. That classic saying, the sun doesn't always shine and the wind doesn't always blow, is true. And this creates a bit of a headache for electricity grid operators, who it's their job to try and make sure supply and demand are always balanced with each other. Now, historically, demand has been the variable factor in there, but with increasing renewables, you now have a much more variable supply. And this creates a lot of challenges. And the way that this is sort of managed in the grids at the moment is by having some reserves on standby at any given time to make up for the shortfalls or over forecasts from forecasts from renewable assets. And the way they do this at the moment is with these large gas spinning reserve turbines, which sort of at a moment's notice can spin up or spin down to take energy or put energy into the grid. Now, the problem with these turbines is they emit just as much CO2 emissions when running at 50% as almost when they're running at 100%. So what we're trying to do is by improving the forecast, we can then reduce the amount of reserves needed on standby at any given moment. And so from rough calculations we've done, we think improved solar forecasts can have the potential to reduce emissions by up to 50 million tons of CO2 annually. And that's a global figure. So our solution to this is by using state-of-the-art machine learning to create our forecasts. And we do this by using historical and live PV generation data. We also use numerical weather predictions. And what traditional solar forecasting models have done is just use these two alone. And what we do is use satellite imagery. Now, these numerical weather predictions, they're quite large, computationally heavy, kind of physics-based models, and they might run on these large supercomputers a couple of times a day. Now, that is not super optimal for cloud forecasting, and oftentimes these NWP numerical weather predictions are optimized for other variables such as wind. And this is where satellite imagery is really useful for predicting solar energy. Not only are you taking a picture of the clouds, which is really useful for kind of figuring out exactly where the sun is shining, but the satellite imagery is updated every 5 minutes, as opposed to these numerical weather predictions, which are updated maybe once every couple of hours. So we feed all this information into a machine learning model, and we have slightly different flavors of model depending on if we're forecasting at the national, regional, or for individual sites. And to give you some context of the size of data that we're dealing with, it's in the order of about 100 terabytes of data that we're feeding into these machine learning models. These satellite images take up a lot of space. And ultimately, we're able to create an improved solar generation forecast from the traditional models. And we recently released a paper at ICLR earlier on this couple of months ago. So if anyone wants to learn a bit more about sort of the model architecture around how we've gone about that, I'd recommend checking that paper out, because we're not going to dive too much into the sort of AI architecture in this talk today. So we have a couple of different solutions. One of them is at the grid level, and our forecasts are currently being used in the national grid to help them with real-time balancing decisions. We do this, we serve up the forecast via an API, but we also have a UI, which is up on one of their screens in the control room. What you have here on the right-hand side is a picture of the UK broken up into each grid supply point region. And what we're doing is we make a forecast for each of these 317 different grid supply points in the UK, which you can then see a forecast for an example here in the bottom left. And then we take all of these individual forecasts and put it through another machine learning model to get our national forecast here. And we can serve this up via this UI and API as not just the expected forecast, but probabilistic bands as well. We've recently done a project in collaboration with the Smith Institute, which has been looking at using a machine learning model to try and balance the grids in a more dynamic way. And from just using our improved solar forecast alone, we're able to save about 200,000 tons of CO2 per year. Now, we're not just operating in the UK, we're also been expanding out to India. So we're working with one of the largest renewable states in northwest India at the moment, doing wind and solar forecasting for them. And that's part of our goal to target some more coal-heavy grids where we can sort of have a greater impact with improved forecasts. And then we're also doing things at the site level as well for sort of solar farms and sort of manufacturing and industry. And also what's getting a lot bigger now is the home energy optimization scenario, where you might have a smart home with solar panels, battery pack, EV charger, and they want to know how all of these different bits of hardware can talk to each other and be completely optimized to save them money and also save carbon emissions. And an increasing market we're seeing now is in flexibility markets, where due to these kind of grid constraints that are occurring, using our forecast in this home energy optimization sort of picture, groups of households can turn up or turn down their electricity supply to help manage constraints on the grids and get cheaper electricity or get some funding from that. So I'm now going to pass over to Sukh to speak a bit more about why we're open source as an organization.
Thank you very much. So now we've spoken a bit about what we do. We want to talk about why we operate the way we do. Why are we open source? As you probably already guessed from our name. The main reasons are increased impact. In terms of capacity, we're a small team. We want people to use our tools as much as possible. By making it open source and free to use, we're hoping we'll have as many users who can build innovative things off of that as well. So use our tools out of the box and also build upon them. We want to move faster. We believe by having an open source community behind us, we have more scrutiny, more good feedback, and also contributions to propel us forward. And also, we found it reduces barriers to partnerships with, for example, national grids, who see us as perhaps more trustworthy, or at least less scary, because they don't have to worry about IP, they don't have to worry about black box models, because they can actually look at our code and transparency. In terms of what open source actually means for us, as Zach has mentioned before, it's code, models, and data sets. So all of our code is available on GitHub. We have over 90 public repositories that people could look through for a variety of things, from our machine learning pipelines and model architecture to our data ingestion pipelines or front-end work. We also have our models pre-trained as basically a set of weights on Hugging Face that can be downloaded and used. And we have 30 different varieties of models actually on there. We also have data sets on there that can be used as inputs to those models. So those are weather data sets, such as numerical weather predictions from different weather providers, which we've been basically accruing an archive of that didn't previously exist and trying to put it into an easy-to-use format. We've also got data sets on things like historical PV output from different regions, so that someone can then actually train a model themselves on that. And we get some very nice images here, like from EU Metsat, of our satellite data archive. So as Zach mentioned, satellite data is generally very big. We actually have dozens of terabytes worth of data on Google Public Dataset as well. This is another rich source for machine learning models if they wanted to forecast things like PV. Given this, we thought that we hoped that people would be able to build off this and build their own models and make lovely contributions. We realized it wasn't as simple as that. It's still really hard to work with large data sets. You need a lot of compute, you need a lot of time to pre-process them. The models themselves are quite complex, and you need a lot of documentation and assistance sometimes to actually use them. So this is where the idea came to, why don't we build an open source solar forecaster that would be really easy to use? And this is where Open Quartz came along, our open source solar forecaster. So what does that actually look like? It's hopefully as simple as this. It's a Python library which you can download, install, and run in 4 lines of code. Essentially, all you need to provide is some optional metadata on the capacity of your panels at the site, and the site location in latitude and longitude. And you'll be able to generate a forecast in 15 or half-an-hour intervals at your specification for up to 2 days ahead. And we are using open weather data on this, so there's no worries about proprietary data. We're grabbing that at inference time, so there's no need to download large data sets beforehand, and it's very quick to run. This was launched softly at FOSDEM in February earlier this year, or March earlier this year. We've had some really great traction with that and contributions, and we'll be talking more about this tool and its progress slightly later. In terms of our overall open source journey, we just want to touch on that. As I said, I think maybe at the beginning we were like, oh, if everything's just open, people will understand it, people will use it, everyone will just jump in. That didn't quite happen. We realized that you actually do have to put a lot of effort into the community you're trying to build and make it accessible to people, make it actually enjoyable to work with. What we've been doing recently is a few things to try and make that easier. So, such as having open office hours, where someone who's actually a user of our tools or is having any issues trying to expand it can come along, and we can have quite deep technical discussions and really jump into what are the issues. We've got some great feedback from that on where we can improve, and we're hoping as well that we can use our open source community to help us improve, so do it in tandem rather than us just trying to fix a thing, work with them to try and fix it together or implement a new feature. We're also now just trying to get more of our community together more often, so doing larger community tech talks, such as things like open source and climate, and getting different people along to share their wisdom. We're also trying to really curate and document our community spaces better. So a lot of that is via GitHub, because GitHub is the natural meeting place for a lot of our community since they're working on code, they're trying to fix issues. So we're trying to make sure like they have discussion areas where they can like ping ideas around, bounce ideas off each other, where we can answer their questions, not just on issues on each of the repos. We also have a more well-structured and curated meta repo now, basically explaining our domains, a traffic light system of which repository is easy to use, easy to contribute to, and which might require a bit more persistence and is a bit trickier, but still we'd love contributions from. And we've been tracking our community metrics to see which of these initiatives are actually working and which ones are ones we should stick with and what maybe we should drop. So in this graph here, we've got our participants over time in any of our GitHub repos for the past 12 months in the light red. You can see the dark red is the comparison basically for the year previous of the same month. Huge spike in March of this year. That spike came to be when we launched our open source forecasting tool, Open Quartz. We had a lot of people jump on, excited to see it, a lot of people who wanted to contribute new features, extend it, and we're trying to keep that momentum going. We've also reached a major milestone at OCF that we now have 150 contributors plus over the lifetime of OCF. So it's still growing, we're still hoping to get more contributors along. As well as perhaps contributions that are a single touch point, we want to foster deeper collaborations, and we've tried a few initiatives to do that. So one of them is ML competitions with university students. So we run Climate Hack AI in collaboration with UCL annually. We have had, I think, roughly 20 universities participate each year. We help curate basically the data sets that they would use during the weekend or the days that they're going to do it, and we help frame the problems. We've had some really innovative stuff actually come out of that, which has been really impressive. So it's nice things that we can take away and then try and fold in to what we currently do. We've tried to basically connect with organizations that perhaps want to do a bit of pro bono work. These might be private organizations. And a nice example has been Trial Labs, a data science and AI consulting company in Uruguay. They wanted to actually build another forecasting model in the back end of our open source forecaster that could be an option, essentially, that you could choose from these two different models. It had really good performance, and they've contributed that and added that in, which is great. We do lots of projects with master students as well, such as in the UK, Elexon, if you're aware, Elexon API is where you can get a lot of energy, electricity data. The API that they have has just been updated, sometimes can be a bit cumbersome to use and grab data from, so we're building a wrapper around that to basically make it as easy as hopefully a few lines of code to grab the data you need. And for the first time, actually, we participate in Google Sum of Code, which we'll be going into a bit more detail about. Essentially, if you don't know, it's an initiative to have more first-time contributors into open source world, and contributors get paired with projects and organizations. Actually, just out of interest, by raise of hand, anyone here been part of Google Sum of Code as either a mentor, mentee, or their organization? No, I'd definitely check it out, and hopefully we'll convince you with the next few slides. So we were lucky enough to have 4 different contributors accepted onto OCF, all doing slightly different projects, but they would have a mentor with Open Climate Fix. So we had 2 main themes. So our first theme was implementing AI weather forecasting models. This was basically, you had state-of-the-art research papers come out that were forecasting weather variables such as temperature, cloud cover, and things like that. Atmospheric variables, there were two main ones that we were focused on that Giuseppe and Lorenzo implemented in the first open code implementations of them was GenCast by Google DeepMind and Fengwu GHR, which I believe was by an AI laboratory in Shanghai. This is great because now if you literally type in on Google GenCast code, these will be your first results because they are the only implementations of there. Otherwise, it's quite black box. Obviously, you can read a paper, but it's very hard then to go from that to code. So this has been really great work by both of them to basically make this more transparent and hopefully for people to actually start using their models since they've actually used them obviously at a much smaller scale than they're originally trained on because we don't have the resources of Google. But still, it's nice that you have these smaller versions of them available online now. The other flavor that we have was improving our open source solar forecaster. So Arjen did a great project in actually integrating live PV data that someone might have access to at home. We'll be going into a bit more detail about that and what that means. And Roche did great work basically trying to, again, find more model architectures and test them out, experiment, and improve our overall forecasting in the actual machine learning side and doing a deep dive into that. On the work Arjen did, this is essentially what was our Open Quartz solar app when you try and run it. So in this state here, you would try and run it. It would grab the numerical weather predictions for the next 2 days, and it would feed that to a machine learning model, and that would map that to the actual solar forecast, so PV output for the next 2 days. The actual machine learning model that was used and pre-trained does allow you to feed in basically lagged PV data. So your historical PV data, what's happened recently, which is a great signal, obviously, what's going to have to come. If you know your PV output now, you hopefully will, well, unless it's a shoulder period, the next 30 minutes might be quite similar. So it gives you a good hint. But we didn't actually have a feature to grab that data, because usually that data is behind a solar panel that's with some hardware, such as an inverter. So Arjen did some brilliant work to basically add this feature in that when you run the model now, you're asked to log in, you can log in with your solar credentials if you have a few certain brands. Once you've done that, it will actually then go to the inverter and the API connected with the inverter and pick up your recent solar panel data and then use that as an input to the model itself. This greatly improves the accuracy of the model since, as we said, it's a great signal that metadata alone can't always be relied upon. You might even have things like shading, you know, a tree might have grown over the last year, that's now on your solar panel. You wouldn't really know about that unless the model knew kind of how that's affected your live output. And it was also a really successful project for the reason that when we first tried to do it, it was just one integration we wanted to do with one inverter brand, essentially, in their API. But Arjen was able to do 4 at the same time, which is great, in the 12 weeks we gave him. And yeah, these were the brands. And the idea is to expand this even more, like get more people involved. We're only able to do these ones because we actually had a human tester. We had someone with these brands that we could actually then use, given an API token to actually test on and actually build the integrations with. Out of curiosity, by raise of hands, who has solar panels in the room, in their houses? Oh, a couple. By of interest, any of you have those? This is now, if you're a real solar geek, you know this, but anyone have those inverter brands within your solar panels? No? That's the problem right there that we're trying to solve, that there's lots of inverter brands. We want to bring them all in. We essentially would want it to be an ideal case that if you have solar panels, we have already done the integration with the inverter brand for it so that you could use this. So we're looking for people, anyone who basically would like to try this, would like to use it to do some forecasting of their own solar PV output, but isn't supported, reach out to us, raise an issue, and we'll hopefully try and get it done, maybe with your collaboration. There are other ways to do it. There are private companies that do this. They basically do that integration layer themselves. They are very costly if you get a quote for them. So we're hoping to do this open source to try and rebuild that a bit. And in terms of what does that actually mean, adding in these inverter integrations, adding in the live data on the results of the forecasts themselves. So if we look at this comparison here, so in the light blue in this graph is the forecasted solar PV output, in the dark blue with live data, sorry, and in the dark blue without live data. You can see quite a difference in the shape and the overall magnitude. In terms of what that means for accuracy, when in this graph here, lower means better because it's average mean absolute error percentage. we've seen a 20% relative improvement if you're using live data in your input versus not using it. So it's been a really beneficial project for us to have Aryan working on this, and he's done some brilliant work. And we're very happy with Google Summer of Code, so do check it out if you're interested in getting more contributors to your open source projects. Jumping back to Open Quartz Solar now, which we mentioned was our open source forecasting tool. So we've had great contributions, as we've talked about in a bit more detail, from people like Aryan, allowing us to have live PV data as an input. We've had more models put in by Treo Labs and our other GSoC participant, Roche. We've added new features to take in tilt and orientation. We're adding in new live benchmarking to evaluate the models. And we've added things like dashboards. The first one, which I've missed off, is probably the most exciting, is that it's over 20 contributors and 51 stars on the repo in the 7 months it's been launched, which is great to see that people are actually jumping on it and using it and contributing to it. And we would love to hear more about user stories as well, about perhaps what we're not meeting. So we're very keen to talk to anyone who's like, hey, I want to use this, but it doesn't support X, Y, Z. It would be great to chat to you, because then we can see if we can make that happen. Obviously, lots of positives from open source tooling and open source in general. We want to chat a bit about challenges as well and how we've approached them. So we've listed 4 here. I'm sure there are many more, and I'm sure there are lots that people can think of. But to start off, for us, it was lots of repositories, and it can be very confusing about where to start. Someone coming in fresh can get basically lost in our code base quite easily. What we're trying to do about that is using labeling on GitHub, writing what a good first issue could be, writing an issue, labeling it with good first issue, making it really descriptive so that someone with quite a little context on the code base in its totality can still jump on it and actually do the work, and also providing some metadata around our code base in general, what the domains are, where your skill sets might match to in terms of front end, back end, machine learning, data engineering, and also in terms of some repos can be difficult to contribute to, try and make that explicit, that we think this might be hard, this repo might be hard to contribute to, but this one actually might be quite easy and basically plug and play as well to use. In terms of the large data pipelines and data sets, we're actively working on releasing these data sets in easy-to-use format, in formats such as ZAR, if you're familiar with n-dimensional file systems. ZAR is really great, and having model weights already pre-trained on Hugging Face as well, so someone doesn't have to start from scratch if they don't want to. We're also building some open source tooling, and that's TBD about when that's going to happen, to try and make it easier basically to stream large data sets over the internet rather than actually have to download anything locally. If you're interested in that, please reach out. We can give you more detail. And finally, how do you keep a growing community engaged? You try and basically interact them as much as possible, have spaces where they can actually talk to each other. We're 12 individuals overall at the organization. We don't really have the capacity probably for every single person that we reach out to get back to them, so we'd love that if it was a bit of a organic flywheel that keeps going, that people who actually may be super contributors to our repositories could actually help other people and keep things growing organically. I'm going to pass back to Zach now, who's going to wrap things up for us.
Thank you, Sukh. So what's next for us at Open Climate Fix? We really want to continue developing AI-driven solutions to help decarbonize the grid. One of the ways we want to do this is by increasing the accessibility to these large weather data sets by working with partners or providing the data in easy-to-use formats, perhaps through an API or other forms that people can use. We want to keep improving our site-level and national forecasts, not just in the UK, but globally as well, and continue expanding around India and targeting other coal-heavy grids. And we're also looking to start doing some behind-the-meter generation modeling in the UK, as well as with some demand forecasting, trying to look at how we can help manage grid constraints there. We want to continue building this open source community, encouraging more contributions to our code base. So we're going to do that by having our office hours and our community talks, as well as we've now got this GitHub Spaces, so people can get involved in discussions there and feel like they are a part of a community. And we're going to keep collaborating with other organizations. We're just a team of 12 people, so having these collaborations means we can use our expertise and other organizations to come together to maximize impact. A couple of the ways that we're doing that at the moment, we were recently selected as a finalist for the Manchester Prize in the UK, and this is for a project that we're doing in collaboration with the Alan Turing Institute, where we're going to be doing cloud forecasting. And we're also about to start another project with Google DeepMind at the moment, where they're giving us access to GraphCast, which we're going to be using to try and improve our probabilistic forecasting in India. And that's really important in India because 9 months of the year in India, it's quite sunny, it's quite easy to forecast, but 3 months of the year, especially when they're having their monsoon season, you could have situations where clouds can appear and disappear in a very short space of time. So having those probabilistic forecasts there are really important. So I want to thank everyone for listening to our talk today. If you want to get involved, one of the best places to start is at our GitHub, which is github.com/openclimatefix. You can scan the QR code at the top right here, which will take you straight to the Open Quartz repo. As you saw from our community metrics earlier on, we got a really big boost in participants when we presented this at FOSDEM, and I want to see if it's going to be the same again this time. So yeah, feel free to join with our office hours. We have a newsletter as well, and if you ever want to find out more as well, feel free to contact one of us. We're happy to give you some demos or tell you more about some of the services that we offer. Thanks everyone for listening, and I think I'll open the floor to any questions.
Just first question.
Yep.
Ooh, is there? Ooh, I think it's coming over.
This is really great stuff. It's nice to see all the effort that's going into making solar forecasting work for the industry, because it's been a real challenge. I was wondering if you were aware that NREL in Colorado just released a PV validation data hub, and I don't know if you've seen that. They have they've created an environment in which you can test out different kinds of PV tools and data analytics and compare them against other tools. And it's like, it basically makes it a lot easier to do some of that comparative analysis that I think you've been trying to do. If you haven't looked at it, you probably want to take a look at that. I also wanted to mention, I don't know if you're aware of the work that Bennett Myers has been doing at Stanford on a lot of the AI kind of unlabeled data sets, right? And I wasn't clear whether you were using labeled data sets or unlabeled, but they've been able to do a lot of things like inferring, the orientation of the solar panels, and automatically detecting shading at different times of year and things like that. And so I thought you might want to take a look at what he and Stephen Boyd's group have been doing with that. It's pretty amazing what they're able to detect just from the power data. That's it, nothing else. They don't even have the geolocation, and they can figure all of that out. So it's pretty impressive.
Yeah, we've done that. Thanks for sharing those both with us. I'm not super familiar with either of those, so we'll definitely have a look.
On the first one, actually, sorry, it came across our desk a few weeks ago. It was in a meeting we were discussing.
It was just released a couple of weeks ago.
Yeah, and we're definitely keen, I think, to evaluate ourselves against that. It feels analogous to me to, I don't know if you heard of Weather Bench, which is similar for weather forecasting models, and a lot of the machine learning ones. Trying to have an evaluation benchmark, and it's great. There's one out there for PV, and I think, we'd definitely be open to that.
And what they're doing is all also open source.
Yeah,
so
which is
otherwise
brilliant.
I wouldn't be sharing it with you.
Any more questions? Yeah, go for it.
You told us that you are working together with some of the solar grid converters working together. Are there goals to integrate to some house automations like Open Hub or Home Assistant or something like that?
Yeah, that's a great question. We actually had a similar comment at one of our office hours where someone was talking about that a lot of people who have solar panels also have like an open hub and stuff. I think it's definitely one for us to look into. We've kind of got it down in our backlog as like a possible integration to do. So yes, and we're very keen if anyone's done something like that before and already have some wisdom from that to reach out and maybe we can do it in quicker iteration than starting from scratch. But yeah, definitely a great shout. Thank you. Just, I think, up at the back.
Thanks for the presentation. It's quite promising to see such a big list of tools. Quick question regarding solar quartz. Is it also usable, or are you thinking about making it usable for, let's say, a longer term forecast? Use case I'm thinking of is like, I want to install a solar panel somewhere. I want to get a rough idea of the yield. Has it been part of what you have developed elsewhere or what you're thinking of for the future?
Yeah, so at the moment, we're just very focused on the intraday and day ahead time horizons. We're not in the sort of, we don't currently have tools for solar prospecting per se, like is this area going to be good in the future? I know there are some already quite good tools out there for that, but it's not something that we currently do. It might be on. I don't think it's directly on our horizons at the moment as a key thing to do. I think at Solar and Storage this year, I saw Google now have their own version of a solar prospecting tool, which seems pretty promising. But
and just a second question, a bit sort of like adjacent or as a follow-up, are you considering also sort of building strategically like in a modular manner what you're doing? Like the reason why I'm asking is because I saw like the way you extended the solar forecast, you essentially put two modules in one, as in like one that actually helps importing data from inverters, which is kind of orthogonal to the rest of the use cases. And I'm thinking just in terms of dependencies, like you might have like two different parallel pathways that could make sense to isolate in two repos and projects. Like just sort of what's the overall thinking, modular or more integrated?
Yeah, I think that's something that we're, to be honest, still figuring out as we go. This is probably like, I think one of the largest extensions of what the feature-wise of what we originally had. So in terms of, I guess personally, modular I think would be very nice. If you could take things in isolation and use it outside of our use case as well, would be great, and apply it to other things. I think we're actually having good discussions around this because we're having more contributors coming in and expressing an opinion of like, oh, we could take this bit out and refactor this bit. So I think it's something we need to figure out, but I'm hoping to go towards the more modular side in terms of that as that tool and be able to, basically pull out a section and say, or even have a separate library if we need to, for example, doing like open source integrations with inverters or Home Hub or something like that, and that you can then import in rather than all in the same repository and becoming very large and perhaps unwieldy. Thank you. Any other questions? Otherwise, I know it's close to 5. And it's been a long day. Cool. Well, thank you very much for coming to the talk. And brilliant. Thank you.